Okay, so today I am going to discuss another problem from CSIR NET 2022 actually. So this problem is from time dependent perturbation, and I will solve this problem and also show you that how to remember. I mean, many of you probably forget the actual formula, what is the factors, p factors in this time dependent perturbation formula. So I will show you a very quick method that if you forget also you can derive it in very quickly in like 1 2 minutes. Okay, so that you cannot you can do this kind of problems in exam hall. Okay, so the problem statement is very simple, and first pause the video and give it try by yourself, and then look at the solution. Okay, so at t is equal to 0, a particle is in ground state of the Hamiltonian. This is the ground state. Okay, now while lambda and omega are positive constant, so you two order of lambda squared, the probability that at t is equal to 2 pi by omega the particle would be in the first excited state of h t is equal to 0. Okay, so the language may be a bit confusing. Let me simplify it for you. So h at t is equal to 0 is what? If you put t is equal to 0 here, this term will vanish. Okay, so h at t is equal to 0 is simply this, p square by 2m plus half m omega square x square. This is the harmonic oscillator potential. Okay, harmonic oscillator Hamiltonian. So the question says that it is in the ground state of this Hamiltonian, and you have to find the probability that it will be in the first excited state of this Hamiltonian. Okay, and this is your perturbation term. Okay, time dependent perturbation. So the language may be now a bit clear, and you have to find the probability at this time. Okay, so you have to integrate from 0 to t, where t is this value, the t maximum, where you finding the probability is this value, 0 to this. Okay, so let's first solve this problem, and then I will show you that how to remember, if you forget the formula, how to derive it very quickly. Okay, so the formula for this kind of problem, that is average of h prime, where h prime is the time dependent part. Sorry, not h prime, the probability. Sorry, the probability c1 dot, let's say, or c1 dot is basically 1 by I h cross. Okay, so here 1 is the first excited state, h prime is this Hamiltonian, the time dependent Hamiltonian, 0. Okay, and if you separate the spatial part from here, then there comes a e to the power I omega t. Okay, where omega is e1 minus e0 divided by h cross. Okay, and for this case it is simply omega, because 3 by 2 h cross omega minus half h cross omega by h cross, so omega is equal to omega for this problem. Okay, so c1 is simply integration of this, so 1 by I h cross 1, h prime is lambda x, the spatial part of h prime, not h prime, the spatial part of h prime. Okay, and you have sine omega t by 2 here. The I am separating the spatial part and the time dependent part actually. Then e to the power I omega t dt. This you have to integrate from 0 to t, and t is equal to 2 pi by omega. Okay, now write it in the operator form. You can write, you can't write, I mean, this is doesn't matter, because the states are very simple, just the ground state and first excited state. But you can write in operator form. This will be very good technique to solve this kind of problem. I mean, if you have other excited states, let's say 2 or 3, then this operator form of x will be very good. Okay, so this is the operator form of x, and if you operate 0 here, a will vanish. This a will, I mean, a0 is equal to just simply 0. It will give you nothing, and a dagger 0 is simply 1. So you will left with one ket 1 state here. Okay, so and ket 1 bra 1 gives you 1. Okay, so it will simply become 1 by I h cross lambda into root under h cross by 2m omega. This is the this term. Okay, bra 1 lambda x get 0. Okay, this is this term, sine omega t by 2, write it as e to the power I omega t by 2 minus e to the power minus I omega t by 2 divided by 2I. Okay, and e to the power I omega t. Okay, now here is 1 by I h cross lambda by root under h cross by 2m omega integration of e to the power I 3 omega t by 2 minus e to the power I omega t by 2 divided by 2I into dt 0 to t. Okay. Okay, so let me write this whole thing as k. I mean, I am not writing this big term every time. So let's write it, denote is at k. So this is k into k by 2I into e to the power 3I omega t by 2 minus 1 divided by 3I omega by 2 minus I am putting this value. If you integrate this, you will get e to the power 3I omega t by 2. And if you now put the limit 0 to t, so in the limit t, it will have this value, and in the limit 0, e to the power I 0 is 1. Okay, so I am just putting the limit after the integral. Okay, e to the power I omega t by 2 minus 1 divided by I omega by 2. Now, if you put t is equal to 2 pi by omega, 3 I omega 2 into 2 pi by omega, this will give you 3 I pi. Okay, and for this part, it will give you I pi, and e to the power 3 I pi and e to the power I pi both have value minus 1. Okay, so it will be k by I am cancelling this 2 and this 2 here. K by is square omega minus 2 by 3 plus 2, right? So it will be k by minus k by omega into 2 minus 2 by 3. 2 minus 2 by 3 is equal to 4 by 3. Okay, so this is the C1 term. Okay, and so let me write it even clear now. So k is our lambda root under h cross by 2m omega. Okay, divided into 4 by 3 omega. So this is your whole term, and if you now square it, you will get the probability p is equal to mod c1 square. Okay, the transition probability, uh, so it will be lambda square into h cross by 2m omega, lambda square into h cross by 2m omega, into 14 by 9 omega square, right? Into, sorry, 16 by 9 omega square. So it will be, sorry, there is a h cross, I guess. Yeah, there is a h cross also here. So it will be h cross square. So it will be 8 lambda square by 2 into 2 and 16. I am cancelling 2 and 16 and giving it 8 9 m h cross omega cube. Okay, so this will be your order of lambda square correction. Okay, so this is that this is, I mean, if you remember this formula, this problem is very simple. Okay, you have to do the integration carefully, nothing more than that. Now the main problem for this time dependent perturbation is most of the time you forget the formula. So I will giving you a simple way that if you, I mean, for every formula, not for this particular problem, for every formula, like in quantum mechanics, classical mechanics, whatever, if you remember what is the source of every formula, how the formula is derived, that will be more efficient way to remember things forever. Okay, if you remember the origin, the source of the formula, then you can remember it for long time. Okay, and that is my philosophy. Okay, so the basic thing is very clear. You have to write I h cross d phi dt is h psi. This is the basic, I mean, Schrodinger equation, time dependent. Okay, so the phi now now if you have a two level state, say Ket1 and Ket2, so you can write psi as C1 Ket1 e to the power minus I e1 t by h cross plus C2 2 to the power minus I e2 t by h cross, because we always calculate transition probability between two states. Okay, so that may be not one or two, maybe two or three, maybe three or four, whatever, maybe three or five, but we calculate transition probabilities between two states. Okay, so these are my two states I am considering. It can be three or five, it can be 3 5, whatever maybe, but two states I am considering, two states, and some amplitude associated with it. This is some time dependent amplitude. Okay, this will fluctuate with time. So now put it at age. Age is some age 0 plus some perturbation. What is age 0? The significance of age 0 is, if you calculate age 0 1, this will give you the energy of the first stage, that is E1, and H02 will give you the energy of the second state, that is E2. This is the significance of H0, and you don't know what H prime is doing. Okay, so now if you simply put d phi dt, now C1 and C2 are time dependent. Okay, they are time dependent probability amplitude. Okay, so first differentiate C1 dot get 1 e to the power minus I E1 t by h cross plus C2 dot K2 to the power minus I E2 t by h cross. This is C1 dot and C2 dot. Now there is another time part, that is this part, time dependent part. So you have to differentiate it also. So if you differentiate this, it will be minus I E1 by h cross K1 e to the power minus I E1 t by h cross minus I e2 by h cross e to the power minus, sorry, it is k2 here, and e to the power minus I e2 t by h cross. Now look one thing carefully. If you multiply I h cross with minus I e1 by h cross, what will it give? It will give simply e1. And similarly, if you multiply I h cross with minus I e2 by h cross, it will simply give you e2. So combining this factor with these two terms will simply give you e1 1 e to the power minus I e1 t by h cross, and e2 2 e to the power minus I e2 t by h cross, right? And what h0 gives you? H0 again gives you the same thing. H0 into 1, there is a C1, C2 sitting here, okay. But H0 into 1 will give you E1, and H0 into 2 will give you E2. So if you now in the right side, when you calculate H0 psi, this will you will get exactly these two terms. Okay, so these two terms will exactly cancel with H0 phi. So what you are left with in the left side is H prime into phi, okay, and these two terms. Now write it again. Okay, so sorry, yeah. So I h cross C1 dot 1 e to the power minus I e1 t by h cross plus C2 dot e to the power minus I e2 t by h cross is equal to h prime 1 C1 e to the power minus I e1 t by h cross plus C2 h prime 2 e to the power minus I e2 t by h cross. Now if you assume that at t is equal to 0, your all particles in this state, this one state and this state has nothing, this state is blank, and after that you are trying to calculate the transition probability, then at t is equal to 0, C2 is 0. Okay, so this term has now no contribution, so you will left with only this term. Okay, so now you want to calculate what is C2 dot, how C2 dot is fluctuating. So I h cross C2 dot into, sorry, there is a K2 here, K2 into K2, and if you assume that they are orthonormal states, then 2 and 1 is 0. So I h cross C2 dot and multiply this e to the power I e2 t by h cross in both sides. So you will get C1 and assumes all particles at t is equal to 0 in this state. So C1 will be 1. So it will C1 will be simply 1. Okay, so if you will get 2 h prime 1 e to the power I e2 minus e1 t by h cross. Okay, so this is the formula which we are using for time dependent perturbation. So it may looks a very long process, but actually it is not. If you remember this basic formula and then write your psi in this format, and if you remember that these two terms will cancel with x05, it will not take much time. Okay, it will not take much time. Only a few time will be taken. Okay, I mean you will lost 2 minutes, but it can be very worthy. Okay, So I will make try to emphasize that this remembering the source, the origin of every formula is very good for any exams. Okay, if you remember the origin or the source of this formula, every formula, that how it is coming, then if you forget also some formula, you can derive it very quickly. I mean, I use this philosophy. Okay, so yeah, that's it for today, and thank you.